Okay, this is a question based on the concept of flux of electric field. Let's read the question. The electric field is in a certain region of spaces 5 I cap plus 4 j cap minus 4 k cap times 10 to the power 5 Newton per coulomb. Calculate the electric flux if S or the area is given as, it's a vector area, right? The vector area is given as 10 I cap plus 10 I cap plus k cap, right? Simple thing. So basically, before we discuss the concept of flux, let's understand what's the concept of vector area. So if I have, for example, an area like this, right, in this area, right, if I might say that this area is, let's suppose, S, right? But then you might wonder, what is the vector? Let's suppose S is equal to 10 meters square, right? That's the area that we are used to know. But the vector area is basically taken with the normal direction. Normal to this area would be a vector. Let's suppose there is a normal. Let's say I draw a normal like this. Now you might ask, so this is, if this is the unit vector along the normal, and this basically, if there is this vector is simply perpendicular to this area. Let's suppose if I draw that, this is perpendicular to any line existing on the surface S. Now the vector area S is given by the magnitude of the area multiplied by the unit vector. Okay, but then you might also ask, so which side should I take? Should I take this one, this side, or should I take this side? It depends on the question in concern and the concept. So basically, the direction of the vector area has to be taken along the context of the question or the problem. Okay, so now here we don't have to worry about it because already the vector area is given as a vector itself. Okay, so flux, how do you find the flux? So basically the definition of flux, right, the flux phi, for, because see, the area and the area could be a variable, the electric field could be a variable. So the flux of the electric field Fie is actually defined in general as the integration over the entire area of the dot product of two things, electric field and a tiny elemental area, sorry, let's write it as ds, right? So let's suppose I write it as ds. Okay, so that's how you find the total flux, correct? The problem is, I mean, in fact, in this particular question that we have, the area is constant over time and space. There is no variable of space and time in area, neither is there any variable of space or time in the electric field, right? So in this question, we can simply see that we can reduce, or we can rewrite this integration as, since the electric field is a constant, so we can take E, then dot of integration of ds, because electric field is a constant, we know. And what about this? Let's suppose I redraw this situation here. This is our area S, right, or just the magnitude actually, let's take it. Now if I take small area ds, a lot of such small areas, when I add, clearly this area lies on a particular plane, right? This particular plane defined by the I cap and k cap unit vectors. So it's a plane area. So if I add all the elemental areas, it is ultimately going to give me as S only. So now what I can do is simply E dot S, right? Because this entire integration will come as like this. Now what about this? This is given as, so this can also be given in the form of vector, that is Ex Sx plus Ey Sy plus Ez Sz. And now let's write down what is Es? Es. So see, one thing is missing in this, right? I cap, k cap is missing, but the j cap thing is there in the, there is a y component of the electric field, but there is the y component of the vector area is 0, so basically this factor will be this term will be simply 0. So now we simply have to find ex and ey. So what is ex? Ex is 5 times 10 to the power 5. It's 5 times 10 to the power 5 multiplied by your 10, right, plus ez. Ez is what? Ez is, okay, actually this is minus, right? So this is not a plus sign, this is a minus sign, because this is minus 4k cap. So it's minus 4 times 10 to the power 5 multiplied by, actually multiplied by your 1, because it's just k cap and multiplied by 1. So let's sum it up. So it's going to be 50 times 10 to the power 5 minus, this is 4 times 10 to the power 5. 4 times 10 to the power 5. Now look, that is simply 45 times 10 to the power 5, because 10 to the 5 taken as common factor, it's simply 50 minus 4, sorry, it's 50 minus 4 is 46, or you can simply write it in scientific form, which is 4.6 into 10 to the power 6. But what is the unit? Unit will be Newton per coulomb into meter square. Newton meter square per coulomb. Newton meter square per coulomb. Okay, that's it. Your answer.